Maths Academy. In this series today we're looking at lesson number 3, where we're looking at the gradient of a straight line. First of all, we need to know what gradient is. Gradient is defined as the ratio of the vertical distance to the horizontal distance, and another name for gradient is slope. Therefore, we have summarized this statement down here that gradient or slope is given by the vertical distance divided by the horizontal distance. Which further, if we're given 2 points and say one point would be like, I would coordinate x, 1 with y, 1, and then another point, suppose we have here a, and then b is having another point x2 minus y2. Then the gradient can be given by subtracting these points, y2 minus y1, which is the vertical axis here, and then horizontal axis would be x2 minus x1, which is down here. So we have some 2 points to note here also, that positive gradients are obtained when the line is running from the bottom left to the top right, and then negative gradients are obtained when the line is running from top left to bottom right. So let's take a look at some example for us to understand gradient clearly. So in this example, we are told to get the gradient of the lines in the Cartesian plane below. Now we have two lines, line 1 and line 2. So the line in yellow is already from the discussion we had earlier. It's going to give us positive gradient because it's running from bottom left to top right. And then line 2 is running from top left to bottom right. So we are expecting a negative gradient from here. So let's identify 2 points on this line 1. The best points we can take would be where the line cuts x-axis and y-axis. Anyway, this one is not so accurate, so we can quote points here like this one is -4 and 0. And then at this point, maybe we say A, and then we can name this one as B, 0 and 4. So given these 2 points, we can go ahead and get the gradient here. Now we can name these gradients point A to have -4 representing x1, and then 0 will represent y1, and we go to B, 0 and 4. So 0 is representing x2, meanwhile 4 is representing y2. So we can say gradient from our formula above is calculated from change in y-axis, that is the vertical axis, y2 minus y1, all divided by change in the horizontal axis, so x2 minus x1. And then we can make our substitution here such that y2 in this point is 4 minus y1 here is 0, and then x2 here is 0 minus x1 is -4. So when we simplify this, 4 minus 0 is 4. And then from the denominator, negative times negative is positive, so 0 plus 4 is 4. And then finally, when we divide this, we get 1 as our gradient. You can see here line 1 is having positive gradient, and it corresponds to the statement up there. Now let's also move on to line number 2, and we do the same. We identify 2 points, so we can have point 1 here, maybe this time let's call it P, and this point 1 has coordinates of 0 and 2. And then we can take another point here and we can call it Q with coordinates of 8 and 0. So here realize that from our gradient also, that is given by y2 minus y1 over x2 minus x1. Here P is having coordinates of 0, 2. We can let it to be x1 and y1. And then Q, the coordinates of 8 and 0, will have x2, y2. Now when we substitute here, our gradient M is given by y2 is 0 minus y1 is 2, then x2 is 8 minus x1, that is 0. So when we subtract the numerator, we get negative 2, then denominator goes to 8. Therefore, our gradient, we can now cancel this out by 2, 1, by 2, that is 4. So our gradient is negative a quarter, and that is negative gradient, as we can see from here, running from top left to bottom right. Thank you very much for watching this video. Please support this channel by subscribing, like this video and share with friends. See you in the next one. Ciao.